Good afternoon, everybody. We're due to kick off shortly. We've got attendees just coming in at the moment. So we'll just give it a couple of minutes. I think we had close to 50 people sign up, which was great. So hopefully we'll have a good 30 or so people turn up. Just give it a couple of minutes and I'll start sharing my slides. Few people coming in. Just give it to 32. Painful silence. Okay. Okay, the numbers have stopped going up now. Right. So I'll just share my slides and we'll get going. So yes, good afternoon and welcome to the ASBP Reuse Now Exploring Reuse Opportunities. Instead of looking at buildings above ground, we thought it'd be really interesting to have a look at what's happening below ground and the reuse opportunities there. Just a quick shout out to our Reuse Now campaign sponsors, Winkelmann Steel and Tubes. Roy's presenting for us today as well as a gold sponsor, and then also Optima as a silver sponsor, and EME, Reusefully, Circuland and Wood Knowledge Wales are our bronze sponsors. So the programme for today, we've got an hour and a half. I'm just going to do a really brief introduction to the Alliance for Sustainable Building Products. And then Andy's going to kick off from Heyne Tillett Steel with a bit of an overview from a geotechnical perspective with a brief look at concrete. And then the remaining three of our presentations are going to be quite steel focused. So we've then got Roy from Winkelmann Steel and Tubes and Iain Bell from Lawrie Tubulars talking about the reuse of steel. And finally, Peter from Winkelmann Construction, particularly focusing on the reuse of screw pile foundations. And we should have a good 20 to 25 minutes of Q&A at the end. Just to give you a quick overview of what we're doing from a Reuse Now campaign perspective. We kicked it off a good sort of 18 months ago now. We have had two reuse summits, one in 23 and one in 24. And a lot of the activities that we do as part of the campaign is to encourage greater reuse of building materials across the industry, both for our members and for the wider construction industry. And we're doing this through a number of different ways, sharing best practice and knowledge sharing, looking at deep dives. We're just finishing one on gas partitioning and looking at another subject, potentially doors for this year, doing lots of work on events like the webinars today and face-to-face events, our demolition to deconstruction events. We had two of those last year and hoping to repeat that for one or two of those this year as well. And obviously sharing case studies again from our members and the wider industry, and guidance documents and reports and articles. So who are the Alliance for Sustainable Building Products? Many of you may already know or be our members, but we're a not-for-profit mission-led sustainability organisation. And our mission is to accelerate the transformation to a healthy, low-carbon built environment by championing the use of demonstrably sustainable building products. And we don't just look at circular economy and resource efficiency. As you can see there, we also look at health and well-being, whole life carbon, ethics, transparency, technical performance and social value. And I'd really encourage you to have a look at the website to find out a bit more about the work that we do. There's a load of resources on our website. You can participate in different research projects. We've got different specialist working groups, and you can register for our events on the website as well. We've also got our Healthy Buildings Conference coming up at the end of February. and a webinar with Buckland Timber on the 13th. So those are our two upcoming events in February. And again, I'd encourage you to have a look at the website. I think probably Larry might have popped the website on the chat there. Couple of kind of housekeeping. Throughout the webinar, you can have questions to Q&A. Please do it in the Q&A, not in chat, so that people have the opportunity to upvote. And if we do have quite a lot of questions at the end in our Q&A session, we can have a look at the ones that are most popular. Please don't raise your hand, and we will unmute the audio of people that are asking questions if you'd like to do that, or if you'd rather not, we can ask the question on your behalf. If you've got any technical problems, please drop a note to Larry in the chat. And as you've probably noticed, we are recording the webinar. But as we say, if you'd rather not have yourself on camera or your audio be recorded, then we can ask you questions for you. So without further ado, I'd ask Andy to unmute and share his slides, please.
Okay, everyone see that okay? Oh, no, wrong one. Does that come through?
Yes.
Excellent. Right, my name is Andy Tyler. I head up the geotechnical team here at Heyne Tillett Steel. We are a structural, civil and geotechnical engineering practice with our own in-house research team comprising engineers, material scientists and software developers. The practice works across a broad range of sectors where both structural and foundation reuse is becoming increasingly critical to the design. So why do we look at reusing foundations? Often we might experience congestion in the ground. There might be requirements for legislation, such as policies in play at the City of Westminster, the retrofit first policy, which is prioritising the reuse of structures. The cost of demolition or construction might be prohibitive. Archaeology might play a part in ground obstructions. And promotion of sustainable practices, and an ever increasing costs of both energy from installation and production of sort of piles and the natural resources required for the installation of any new foundations. From a geotechnical perspective, first and foremost, when we're looking at the reuse of foundations, we want to assess the existing versus proposed loading condition. In relation to the new development, we're looking at the foundation geometry, and we're looking to verify the soil strength as well, to ensure any foundations are fit for reuse. In assessing the existing versus proposed loading conditions, we first need to understand the existing foundations on site. This often requires an assessment of the archive information, any historic design approaches that might have been adopted. And we might then adopt our modern design approaches and see if we can permit any increases in the design load without compromising performance or indeed requiring any additional strengthening works. Following on from any preliminary desk-based assessments, site investigation works would aim to confirm pile diameters by exposing them physically. We need to match those with the archive records to ensure we've got compliance with the two. And we also need to ensure the soil strength on site aligns with what we've maybe has been adopted for the former design and what we're going to be assuming in our updated design assumptions. So in confirming the length of the piles, and I'm talking specifically about piles in this sort of case study or this presentation, the confirmation of length on site, we can do that in a couple of different ways potentially. We can look at drilling a borehole next to the pile and undertaking some testing known as parallel seismic testing, where we measure the seismic waves traveling through the pile to estimate a toe level. In addition to using that methodology, we might adopt a magnetometer, which will allow us to confirm the depth of reinforcement in the pile. If we want to physically prove the base of the pile toe, then we might adopt a coring technique using a rotary drilling rig or something similar to get down to the toe depth. Once we've undertaken our sort of preliminary geotechnical assessment, of the foundation reuse, our focus will turn to the material properties. And in looking at that, we're going to need know a little bit more information about the concrete. We want to know a little bit more about the material strength and condition, durability and aging, material composition, and the structural integrity. To assess material strength, we'll be taking samples from either the side of the pile, if we can get access. Maybe we'll take a core from the top of the pile. Those samples will be taken to a laboratory and compressive strength testing will be undertaken. And at that point, we might get an indication of what the concrete grade is. While we're looking at the piles, for exposing the side of the pile, we're looking for any defects, any sort of issues with the pores, or any sort of indications there might be some problems. And at this point, it might be an opportunity to confirm the reinforcement details as well. So undertaking a cover meter survey to check the reinforcement diameters, depth of cover, spacing. These are extreme cases. When we're doing visual inspections, more often than not, we don't see anything like this, but this is just to give you an indication that we're looking for things like corrosion of the reinforcement, spalling of the concrete, cracking of the concrete. And in my experience, as I say, this is not often, or rare, if any, we come across these sorts of defects. So with regards to durability and aging, there are a number of processes that can impact the performance of the foundations, specifically where reuse is concerned. Carbonation is one of those concerns, and that's a process whereby CO2 in the air reacts with the concrete, lowering the pH and creating water. The process eventually begins to attack the rebar, and the reinforcement rusts, expands, and cracks the surrounding concrete. This process is particularly prevalent in above ground structures, less so for below ground structures like foundations where air circulation is limited. So to investigate the depth of carbonation, we apply a purple dye, which is sort of pH calibrated, to core samples taken from the side of an exposed face of the foundation. And that will give us an indication of what the depth of cover might be before we get to the reinforcement, and give us an indication of maybe the timeline we might have on that particular sample or concrete. Chloride ingress. A chloride attack is a process whereby the ingress of chloride ions results in the corrosion of the reinforcement, and this causes expansion and cracking of the concrete. This is quite prevalent in marine and salt-rich environments, not particularly common in the sort of urban environments that I'm working in typically. So one of the more prevalent attack mechanisms that I come across is sulfate attack. It's probably the most common method of attacking in below ground structures. This process involves the penetration of the concrete by sulfate solutions, which results in expansion and softening of the concrete. Sulfate is prevalent in poritic rich soils such as London clay, which is present across the majority of the London basin. It can be present in both soil and groundwater, and can be exacerbated where poritic soils are allowed to, or exposed, reworked, and allowed to oxidize. As part of the site investigation processes, we'll take samples of soil and groundwater and have those samples tested to provide design sulfate classes for any new foundations that might need to be constructed on site to supplement the existing arrangements. As with chloride and carbonation attacks, the adoption of a low permeability, low cement to water ratio cement or concrete with supplementary cementitious materials and reinforcement coatings can restrict the impact of these sort of attack mechanisms. Other mechanisms we might see, but probably less frequently in the work that I do: freeze thaw, water leaching, alkali aggregate reactions, and acid attack. One of the important elements we need to assess or establish is the material composition of the concrete. And usually that's undertaken by petrographic analysis. Now that's samples or thin section samples are taken from the concrete samples that are taken from the side of the pile. We're looking at the cement type, we're looking at the aggregate composition and grading, water to cement ratios, the presence of any admixtures, any supplementary cementitious materials that have been added, and any air bubbles that might be present in the cement mix or the concrete mix. Lastly, consideration needs to be given to the structural integrity of the pile. This covers anything from pile installation defects to being compromised by external factors, maybe following installation, demolition might induce horizontal cracking in the pile head. And we might see chemical attack processes in play once we've exposed the sides of the piles, as we talked about earlier. When we're looking at reuse, there's a couple of good sort of guides and resources to consider. The BRE have released a best practice handbook for assessing reuse, and there's lots of useful literature or useful case studies on the Concrete Centre and the iStructE websites if people are interested. Okay, that's it.
That's great. Thanks very much, Andy.
Okay.
How many clients would you say are looking at the reuse of foundations? Is it something that you kind of have to propose, or is it something that you're being asked about?
I think it's a default position for us from a sustainability perspective that we would always look to reuse foundations if we can. There's in my mind, no excuse why we shouldn't be reusing foundations. Obviously, there's positions or situations whereby reuse isn't necessarily the best option and strengthening might be required, but the wholesale, we'll try and mitigate the wholesale removal of, any connectivity with existing foundations if we can, because it's, as I say, it's not really good practice. So we would probably be driving that from our side as a first pass. We're looking at reuse if we can. If it doesn't work and we really can't justify its reuse, then we may have to look at alternative solutions.
Okay. Super. Thank you very much. And moving on now to Roy, please.
Thank you very much. Just pull up the slides if I may. One second. There we go. So does that come up okay?
Yeah,
Brilliant.
thank you. Thanks, Roy.
So very simply, we've been doing steel tubulars for piling and propping for 50 years. That's what our business model was and is. So we've always been in this marketplace. What we're basically doing is repurposing oil industry material, because the oil industry generates huge volumes of pipe. It generates waste by surplus. And to give an idea of that, you can be talking about literally thousands of tons. I'm aware of a job where the overrun production was 36,000 tons. That's without jobs that get cancelled. It's without jobs that get changed or adapted. There's then also the downgrade material that comes from the mills, and it isn't acceptable to the oil contract that it was built for. Doesn't mean it's defective pipe. It just might mean it's a bit short. It might mean an end detail isn't correct or whatever else. And then you've got the second-hand material, which can be pool casing or oil lines, gas lines that have actually been lifted. Weirdly, it's at a point now where with gas and oil lines on the seabed, they are actually having to take them up because it's so busy down there that the number of crossings make it more viable to lift an old line out of the way than to leave it there and try and get one pipeline laid across another. Used material was a lot more commonplace in the larger diameter stuff. I won't put words in Iain's mouth. He's coming later. They deal in the smaller stuff. And as we stand at the moment, there's at least 500,000 tons of ex-oil field material, oil pipe available within Europe. One big thing about the piling industry is that they're actually specifying API grades. So this is such a valid historical process that when we get piling specifications, sometimes they actually specify API X65, X70 grades rather than the construction grades such as S355 or 460. So one thing I would say is that sometimes it won't be the case that suggesting that using steel tubular piling and having reused material is going to be a carbon saving, because you may actually find that your piling contractors were going to do it already. One other thing I would say, though, is that we've done a lot of work now with reclaimed sections, and we talk a lot with engineers, including Heyne Tillett. But it still is the case that when we see a project come through as a new project, a new build, it's from the ground up, and we'll see some sort of hazy sketching to do with what's going below ground, but it's often handled by others, different contractors, etc. So it's definitely always worth considering that although the new shiny building that everybody's going to be impressed by needs to have a low carbon footprint, has anybody actually given thought to the circular economy and carbon impacts of the below ground works? And that includes the temporary works and propping as well. Still is the case that cash is king. I know we're trying to do sustainable things, but in actual fact, reuse typically will offer cash savings versus new material on the steel. If it's big stuff, it can be up to 50% savings. Smaller stuff, it's perhaps not as high. And if you're reusing your own materials, so looking at what you've got on site or what's already within the system, then clearly that's going to bring a big saving. So we shouldn't forget the prospect for financial impact. In terms of the carbon impacts, we had our EPDs done last year, signed off. Just very quickly put, if you're looking at steel, new blast furnace steel is about 2,000 kilos per ton carbon for steel. Electric arc, which is where we're headed when we've actually eventually get the new electric arc furnaces in the UK, is about 700 kilos. That can be reduced with various offsetting for power and one thing or another, but the production cost realistically is about 700. In terms of reuse, if it's second-hand and surplus, as in waste, then it comes in at 70 kilos, which is a massive saving. It's 90-odd%. If it's byproduct, which is essentially the overruns from the mills, then it's about the equivalent of EAF. So it's still offering a good low carbon solution. In terms of the byproduct, it's worth remembering, and I'll come to it in a case study, but oil field sizes are bespoke. So very often there's some very, very funky sizes that come out of the oil industry compared to what people expect to see through the normal construction specifications. Doesn't mean there can't be equivalents, and it certainly doesn't mean they can't structurally do what's needed to do. In terms of applications, micropiles, not my thing, again over to Iain Bell in due course, but casings, jetty legs, dolphins, so that's a lot of marine work. But restraining walls, combi walls, props, and then monopiles and basic piles just straight under structures. So we're seeing material going into all these applications. Temporary works consume quite a lot, propping as well, and reuse and circular economy are fundamental in these areas because a lot of times the carbon may not be accounted for through the construction process as it's classed as temporary, but I would argue that means it's even more important that that carbon and steel isn't wasted and that stuff is reused or has been manufactured from reused materials wherever possible. So a few case studies. I mean, we've been doing this for 50 years. We're doing 20,000 tons a year, so there's a lot of potential case studies, but a lot of what we've done is marine work and a lot of it is ground stabilization. It was interesting listening to Andy talking about concrete because that's the one thing I do see on the large structural stuff in London is you'll see the assumption that the piling is going to be concrete. I'm not convinced that it necessarily has to be, but that is often the case. And there is a lot of sort of drill and pour concrete piling going on. So one example here would be Port of Dundee a few years ago now. So 36-inch 914 pipe was specified. This is where I was talking about funky sizes. We actually had 911.8 by 28.9. So it's a non-standard diameter, non-standard wall. 1,070 tons were required in long lengths, 18.7 to 27 meters approximately. And this is one of the big advantages of steel, which I will mention, is that a lot of times, although the ground surveys have been done, we always joke in manufacturing piling that we usually get to plan F, G, H or I when it comes to actually fabricating the lengths, because when they start knocking them in, it turns out the ground isn't behaving as was expected, so the piles are either too long or too short. The big advantage of the steel piling is it can be extended or shortened. And again, if you're buying it from a stockholder like ourselves, then we're trying to sort of supply just in time, so we're often able to adjust the lengths without the purchase having been committed. If it's all bought brand new from the mill, then in actual fact, you're going to have to place your order for 1,070 tons of specific lengths, and that is what's going to be turning up. And then you've got to try and fix it thereafter. So the reclaimed and reused material, because it's available from stock, does offer you that flexibility in application when you're piling it. In terms of this particular job, 1,070 tons of pipe, the estimated carbon saving was 2,185 tons. So these aren't small numbers. And it's often the case that there's a lot more steel underground than you might allow for. And that can have a big impact on the project carbon cost. Last year, and I do hope I've spelt Brownie right, but Brownie Curve, it's a network rail job. Basically, the railway was sliding into the Tyne, I believe. So they had to do a big chunk of ground stabilisation. We did a job with them the year before, and it's the case now that they are looking for lower carbon solutions. So they're looking towards reclaimed and reused material. The original job was basically all 24-inch by 20 and 25 mil. We didn't have anything like the quantities that were required. There's actually 5,000 tons on this job. But what we did have was an array of sizes that were able to structurally satisfy their requirements. So we actually supplied everything from 24-inch 610 diameter up to 686, I think was the largest, and the thicknesses varied in the end up to 32 mil. So they ended up in many cases with stronger material, but for the same price or less than the material they're looking for. It's a great thing about piling is that usually the solution is flexible. It's required to perform a structural function. There isn't usually a cosmetic element. So you might set off, we see jobs that set off requiring a 20-inch diameter, and it might finish down at 14-inch or up at 36-inch. And they just change the configuration of the design, especially for ground stabilization. The other thing which was great with this job is that they took on board that we couldn't supply the full quantity, but utilised the most that we could, and then we supplied the balance in new material. So it was a 5,000 ton project that was able to use just over 3,500 tons of reused and repurposed. We've split it down into the different categories representing the different carbon savings. But overall, compared to new tubulars, which are currently basically in larger diameters, all made through the blast furnace route, that 3,500 tons has saved nearly 8,000 tons of carbon. So that, again, big numbers, and it was really nice to see that the likes of Network Rail are starting to think like this, because it's been a long road in that regard. This was an older job, 2017. Arslef, I think, were doing the piling, and it was a mega turbine up in Scotland at Hunterston. So the foundation for this thing, I think the wind turbine stood at 300 meters tall, but the foundation for it was colossal. So this goes to my point about what sometimes you have to do to achieve an above ground structure. For the above ground structure, which you can see, they put nearly 1,400 tons of steel in the ground, and that's without the concrete and everything else that went with it. Again, they had very uncertain ground conditions, so we were supplying this material virtually on a call-off basis. They would determine what they required the following week, and we would make sure those lengths were being supplied to minimise the waste. There would still be some waste, you can see from the pile tops there, but we were able to prevent them having to use maximum length for every scenario. Because if you're going to order this whole 1,400 tons from a mill, you've got to go to the longest length you might lead and order all of it at that length. You can't afford for anything to be short. So we were able to save, I can't quantify what that would have saved, but in terms of the steel itself, again on this job, 2,380 tons of carbon saved. Now, granted, we're talking about big numbers, but equally it applies just for a single pile. You can be saving over a ton of carbon versus steel, and we're more than happy to supply the smaller jobs as well as the larger ones. Apologies, I'm sort of fairly rattling through and I'm not sure, I haven't kept track of my own time, but just to a little bit about ourselves. So we've actually, this is an old slide, we've actually got 88,000 tons of tubulars now, 4,000 tons of sections. We can offer fabrication, painting, testing. So we can basically offer a one-stop shop piling and similar marine type large tubular activities. And similarly for normal sort of industrial work, if you like. So we've done a lot of foundations for factories and buildings otherwise. Logistics sometimes are an issue. If you go in somewhere like the central London and you want something to be 25 metres long, getting it there might be a problem. But those things can be addressed, and I would like to think Iain might be going to touch on some of that with some of the jointing techniques as well. Steel is a very flexible solution. So that's us. It's Cleveland Steel. We've been around for a very long time. Very happy to field questions and definitely field inquiries going forward. And that's it from me for now. Thank you.
Thanks very much, Roy. That was really, really interesting. And obviously, having heard you speak a few times before from more of a building perspective, it's interesting that quite often the reuse of a material is seen as very inflexible because supply doesn't meet demand, or it's not there at the right time for when you need it. So it's really great to hear kind of the flip side of that, particularly with the below ground, to say, if you ordered it all up front, you'd have to order it all the same at this maximum length. Whereas being able to call off from a reuse perspective, you've got that flexibility to say, actually, we thought we'd need them at this, but can we swap round and do it at this and this instead? So yeah, that's really interesting. And equally, I know for above ground, you kind of encourage the flexibility from design teams to say, try and put a little bit of a plus and minus around what your specification is to enable that additional flexibility, so that you possibly may be more able to look at reuse rather than be so hemmed in to your designs. And obviously the Port of Dundee example there, where you were just the tolerance wasn't quite bang on to what they specified, but they were more than happy to take what you'd got that was close to that and would still do the job.
Just to pick up on that, you'd be surprised how far the piling guys can move from what they originally think they need. So if I take the 610 by 25 on the Brownie curve job, we were supplying 660 by 32 as some of that. So it's more than 10-15% out of what was the original thought process. But the piling industry is very good at doing this, and they always have been. So they're very accepting of the approach. Now, as I say, historically, it's been about money, if I'm honest. It is equally valid for carbon.
Fantastic. Thank you very much. And we'll hand over to Iain now from Lawrie Tubulars. Thank you.
Hello, does everybody hear me?
Yeah.
Excellent. Let's bring up my slides now. Okay. Hopefully everybody can see that screen okay.
We have still got the grey boxes, so I'm not sure.
Hopefully they go away. I can't seem to get rid of them.
Yeah, well, I don't think it's going to take away from your slides. It's only
No.
a couple of little bits, so I think it should be fine. Thanks,
Yeah,
Iain.
no problem. No problem.
Oh. You've just put yourself on mute. Sorry, Iain.
Okay. Can you hear me now?
We can, yes, thank you.
Yeah, sorry about that. Yeah, so wait, there we go. Yeah. So my name is Iain Bell. I'm the general manager for Lawrie Tubulars. So I'm just going to get into this here just now. So at Lawrie Tubulars, we started off in 1981 as part of a metal recycling company based in Aberdeen. We are a steel stockholder, but similar to Cleveland Steel, what kind of sets us apart from other steel stockholders is we procure surplus and used steel tubulars from the oil and gas sector. Since our beginnings, we have been supplying repurposed steel pipes into the construction sector, mainly for top-driven piling within the housing market. In more recent times, we have invested significantly, allowing us to support different sectors within the construction industry. So what does it look like for us to procure this material? I've added this into a 6-step process. As mentioned before, we purchase the redundant or surplus steel pipe from the oil and gas industry worldwide. The steel pipes are then transported via road or ships to our yards that are strategically positioned near key sites to minimise unnecessary transportation. The second step would be the actual locations. So we have our main yard, which has our machine shop and fabrication team, which is based in Montrose in the northeast of Scotland. And we have a small storage yard in Scunthorpe. After the material arrives at our yard, we go into step 3, which would be the inspection of the material. The pipe is fully inspected and it's cleaned if required. The pipe which is unsuitable for reuse is then fully recycled, and all suitable pipe is stored in bays ready for orders. Step 4 would be what I would call our value-added process. We've invested significantly in a purpose-built machine shop. Here we process a pipe to our customer specifications. Our machine shop includes a friction welder, 7 CNC lathes, 1 large diameter saw and 4 semi-automated saws. Step 5 for our process would be our quality control. With our experienced team of reliable coded welders, our machine operators ensure that all products are manufactured in-house and are to a high standard. All the threading and the joints and pipe are carefully inspected before being loaded. And then step 6 would be the delivery. We have deliver pipes all across the UK, and they're all loaded onto Artex or pallets, however they would like it on site, so that they can pile it as soon as it arrives. So I'm going to give you over the next few slides some real life examples of the pipe we get in, what we manufacture it to, and then some case studies based off of that. First up is an example of some surplus material in our yard, and on the right is a picture of friction welded drill rods that are manufactured in-house. Our casings and drill rods are often used as part of the installation of ground sourced heating. For this particular project, it was for a central government department. Our client installed an open loop ground sourced heating scheme for a large public building. The project consisted of initially drilling 2 boreholes to facilitate the testing of the ground's capacity to support the required flow rate and return of water, which needed to be at 32 litres per second. The first borehole was drilled to 550 metres, the second to 380. Both were lined with John Lawrie Tubulars repurposed casing pipe, which supported the main contractor's decarbonisation ambitions. With the re-injection borehole proven to be effective, this project was delivered on time, on budget, and to an environmentally effective standards. Our drill rods are friction welded and heat treated in-house, and we are the only UK business with our own friction welder dedicated to the manufacture of these drill rods. Our yard up in Montrose, we typically hold about 25,000 tonnes of stock. And on the right is an example of some of our repurposed casing pipe that has been slotted. These slotted casings are used in both landfill and water well drilling. Our clients drilled boreholes on landfill sites for water, gas and leachate extraction throughout the UK. The drilling operations, they used these steel casings to stop the ground from collapsing. On this particular project, John Lawrie Tubulars, we were commissioned to provide 244mm and 406mm casings for the use of their extraction sites all over the UK. The 244mm casings are used on permanent installations to hold the ground open to install their pipework, and the 406mm casings are used to keep the hole open as they do the work in the drilling. The gas that is extracted from these sites is flammable, it's odorous, and it contains a large amount of greenhouse gases. However, the company that does these works, they have still found a use for this. Once it is extracted, it is transferred and utilised for energy generation. The leachates, that's what leaks down into the liner base of the landfill site. It forms a drainage blanket where part of the soil becomes oversaturated with a puddle of toxic liquid from the disposed waste. Our clients remove this from these landfill sites from up to 85 metres deep underground, and they build a borehole which will allow the gathering of the liquid and prevent the drainage blanket from reforming. Our sustainable, the picture on the left here shows our cut stock ready for delivery to site, and the picture on the right shows a piling rig installing some of our tubes. So our repurposed tubulars, they're most commonly used for the top-driven piling market and as an alternative to precast and concrete piles. It is superior to concrete when the ground conditions and installations locations are tricky. For this particular project, we supplied around 500 244 diameter steel pipes for the foundations for 3 blocks of flats constructed in Edinburgh. We helped our customers work towards their net zero goals on this contract, and the main contractor was able to save an incredible 1,100 tonnes of carbon using the repurposed material. Top driven isn't only used for housing, it can be used for a wide variety of industries, as seen here at the Yarm Viaduct. For this project, it was aimed to address the structural weakness of the viaduct's foundations, necessitating the installation of 656 178 diameter steel piles to the depths of up to 13 metres. The ground conditions were soft clays overlying sandstone, meaning the steel pile solution was the best solution. Steel transverse beams were strategically placed through the existing brickwork piers, which were supported by piled reinforced concrete caps. John Lawrie Tubulars piles, they were supplied using a jack down piling technique, which is in the picture there. This particular method was selected as it's quiet, there's no vibrations in the installation process, and so that significantly reduces the risk of the disturbance to the existing structure. We also manufacture boss piles and threaded pin piles for the rail sector. Our dedicated Montrose facility, we are accredited to BSEN 1090 and RISCUS, which means that we can fabricate any pile requirements in-house. On this project, we supplied over 1,800 metres of 457 and 339 millimetre pipe. It was used in the foundations for the Brent Cross West station. Our clients for this project, they installed 193 piles using 2 different techniques. They used the vibration with a Movax and then an impact hammer. We've been working hard to educate the rail sector on the benefits of using repurposed steel. However, there are still some challenges we face. Educated engineers at the design phase to incorporate repurposed steel to their design. Quite often we'll find that maybe there will be a requirement for prime material, and as Roy said, it will be a particular size that you're not getting in repurposed material. And by the time it comes to us, to be able to change that design within the rail network is very, very difficult. And you'll find that maybe the pile is holding up a sign at the side of a railway, something that it doesn't need to be prime material for. So some of our best practice that we're looking going forward and how we're incorporating new technology. One is our life cycle analysis. So for every project, we can accurately calculate the CO2 saving versus newly milled steel. We do this using our bespoke LCA, which was commissioned in 2020. The data gathered was far-reaching. Everything was covered from where we source our steel, the transport method used, how many pairs of gloves we use every year. With this information on our LCA, we were able to calculate exactly how much carbon our repurposed material produces per 1 tonne of repurposed steel. Doing this enables a direct comparison to carbon created by prime steel being used in the same job. The result of our LCA was for every 1 tonne of John Lawrie repurposed steel tubes, it saved 2.163 tonnes of carbon, or 97% compared to new material. How do we use this though? It's a nice figure, but how do we use it? We've settled on a certificate. and we presented these findings in this meaningful way to both our suppliers and our clients. We can offer this certificate per year, per month, or even per job, and we like to see that it could maybe be added into the job pack that's maybe handed over to the main contractor, the main client at the end of the job. So as you may have already realised, in recent years we have diversified our product range and increased our bespoke fabrication services, and we do more than just resell steel tubulars now. We haven't got time to go over this, but I haven't included this video for anyone interested in seeing our team in action. So hopefully these slides are made available following this webinar, and you'll be able to watch the full thing there. And a final note from me is that from us, that we've learned as a business in our industry, offering customers a peace of mind is essential. We guarantee that our products are sourced ethically, made effectively, and delivered sustainably. So with that, I thank you very much, and I look forward to hearing any questions that you might have.
Thanks very much, Iain. That's great. You mentioned from a sector perspective that you work a lot with the house builders and rail. Do you find sort of other logistics or other smaller projects in other sectors are as open to reuse steel, or is it particularly resi and rail that is biggest for your market?
So our biggest market is definitely is the house building and the commercial. You know, that's kind of similar to Roy. Our experience of working with them teams is very good. It has been now breaking into the different sectors where we're finding it. So breaking into rail has to use repurposed material has been challenging. But now it is other sectors where the energy sector, for example, you know, where geothermal can be used, you know, drilling holes, casing pipe, does it need to be new material? No, it doesn't, for them projects, and bringing people together and having an open discussion, because as a country, as a nation, that's where we need to be. We need to be having open discussions about repurposed material and being able to use it. You know, I would like to see it being, that's the first question when a project comes on board. What can we reuse, you know?
Fantastic, thank you. So I'll finally, last but not least, hand over to Peter from Winkelmann Construction, and then we'll do a Q&A with all of the panel. We've got a few questions coming through already in about 15 minutes or so. Thanks very much, Peter.
Debbie, thank you very much. Do you see my screen?
Yes, we can, thank you.
Okay, that's great. So good afternoon, everyone. My name is Piotr Babst, and I have a pleasure to represent Winkelmann Foundation Screw Company, WFS. We are located in Poland, but first of all, I would like to thank you really for the invitation to this webinar. I think, and I'm really pleased to be a participant in this webinar and to talk or participate in the discussion about a very important topic. It means exploring reuse opportunities, particularly for the products, materials which are below the ground. We are really specialized in screw piles, and therefore today I am really pleased to present you my presentation titled a little bit provocatively, "Why are you still digging and pouring concrete? Use and reuse our Winkelmann Foundation screw piles." Well, I would like also to introduce you to my colleagues from Poland, which are with me. Marta Dominiak is a commercial person responsible worldwide for our clients, also in UK. And Kacper Smulski is our structural engineer, head of structural engineers, and he will address any technical questions during the Q&A session. Before I really dive into the details, I would like briefly explain you actually our company, why our company has chosen this path of development. And as I mentioned, we are the manufacturer of innovative screw foundation piles, which should really achieve three key objectives, I would say. Yeah, the first one is to eliminate the wet processes on construction site, by replacing traditional concrete foundations with steel, with a steel screw-in foundation piles. Second objective, it was a radical reduction in foundation construction time. And the aim was 70%. And through this system, we can achieve even much, much better results. I will explain it. And the most important one, the third one, was the ability to reuse screw piles, which introducing a completely new level of thinking about the really foundations in the construction. And in our thoughts, we believe that such approach is a really response to contemporary environmental and economic challenges. So the question still is valid. Why are you still digging and pouring concrete? And I will try really to explain you during this presentation. I will start with our DNA. We are Winkelmann Group. We belong to the German group Winkelmann with the headquarters in Aalen in Germany. We have already 125 years of history and really development history. At the moment, we have 13 production plants around the world and also 12 distribution centers. We employ 4,000 employees and we have a very big location in Poland. There are 4 plants altogether. And from, I would say, industry perspective, we are the supplier of the parts for engines for largest car manufacturers like Bentley, BMW, Volkswagen, and other ones. Second segment which we serve is a heating system or heating system industry, where we produce also water heaters, expansion vessels. But that what really connect all the businesses is a unique technology. And we are the leaders in metalworking. We patented, developed the technology which is called flow forming. And coming to the piles, to our baby, I would say the piles, as you know, are very, very old. Yeah, so this is not new ideas. Or more than 6,000 years ago, wooden piles have been applicated. But only 200 years ago, screw piles are invented by Alexander Mitchell. And this is a relative new history for the piling systems. What do we do? Very short overview that you understand really what the presentation concerns. We produce 2 systems of screw piles. The one system is on the left side, is a modular one with a diameter of 140 millimeters. And the second one on the right side is a little bit smaller for lower loads, monolithic system, 89 millimeters. And I will talk particularly about the left system, which is a modular one, because he's particularly dedicated for a little bit higher loads. And also you will see through the applications how it works. So all the systems are hot dip galvanized, so they are protected against corrosion with the zinc coating of 70 micrometers. We use for both of them flow forming technology. We have some patented solutions, particularly for the connections between modules. And we have a very unique shape of the helix. There is no welding technology really involved. This is this flow forming technology which allowed us to produce all these elements in one piece. Okay, if you look at the system, really the modular system consists, of course, of, I would say, modules, which are presented here, the base module, extension module. We call the last one on the top head module. And also we equip our system in the special connection plates, which could be standardized or customized, really according to the needs of the structure which is above installed. We use also some additional elements to transfer higher vertical and horizontal forces, the so-called boosters. These 2 elements. And if we need really the higher load bearing capacity, and particularly if we want to achieve higher capacity of our piles against vertical forces, what we do, we can really group them in the groups and connect them through the reinforcements like bracings. But also we can ensure, if it's necessary, really the bending moments, which are much higher. We can collect also our piles through the traverses systems or so-called beam connections, and then we can really collect 2, 3, or even more piles in the groups. Applications. I will jump really very shortly through the applications because you know, this is a specific product for specific applications, starting from modular houses. This is a very good system, really very good system for modular houses. Why? Because it's a very quick installation, because we do a very low impact on surrounding. We use really any heavy machines, and particularly we can install the house structure above immediately after the piling system has been installed. And for such house, which is here shown on this picture, it's around 100 square meters living area. We need just 1 day to install all the piles which are required for the foundation of this for the structure, and we can immediately really install the house over that. So the 2 days and the house is ready. Containers, it's the next application. And as you know, containers buildings are almost more popular and construction business, particularly in Europe. Why? Because installation can be done in every weather and quiet and terrain and all terrain conditions. What is very important, our system is fully reusable. It means after the installation of the containers, also our screws can be really unscrewed and can be used again. And very easy to assemble, because we screw them into the ground, and then after the certain period of time, we can screw them out. Photovoltaic, and this is a huge industry in Europe. It's growing industry in Europe, not only in Europe, also in US and other countries in Asia. But this system, which we really deliver, is presented here particularly for carports, because we can ensure also the high uplift applied forces resistance. And what is important, we can very quick assemble the installation of the foundation, and we don't really destroy the surface, existing surface. For example, in the front of the big markets where the customers already really park the cars. The fourth application is infrastructure, and Jan spoke about the Brent Cross West Station project. I think this is familiar to that what we can do, and we do in infrastructural businesses. Blackout time reduction is very important, and with the speed of installation, it's a really big advantage for this technology. We also don't create any vibration. It's very, very important. Sustainable foundation system, really, and also in infrastructure, we can install our systems in every weather and every ground conditions, quite, of course, in every ground conditions. And very quick overview, inspirations for you. Modular houses, frame structure, temporary modular houses, you know, houses on water. We have already some examples of such buildings with our foundation screws. Containers, schools, tanks, storages, field hospitals. Photovoltaics, as I said, one of the fast growing markets in continental Europe, but I think also in many countries in the whole world, starting with the carports, which are really very popular. Photovoltaic agro, France, Italy, and some other countries, almost more popular segment. Photovoltaic farms, this is also a good, I would say, area for usage of our products. If we go to the infrastructure, it means, I would say, mainly roads investments and railway infrastructure. Then you can see our screws can be used for acoustic walls, can be used for the lighting posts, for the lighting systems, different kind of passages, bridges over the small bridges over the roads, and also over the railways. And if you look at that, what was presented in this project, Brent Cross West Station, we can also use this our systems and infrastructure. That are the posts, telecommunication posts, could be the posts for energy lines and so on. And if we speak about the energy, this is also a very important sector or application for us, starting with substations, transmission towers. All these elements can be really used or can use our screw pile systems. And finally, if you look around in your gardens, you will find also some solutions or some applications where this kind of products can be used, starting with bridges and walkways in the gardens. Also temporary halls and some street furnitures. Everywhere where really the loads are punctually translated to the ground, we can use our technology, and we do it. And my presentation, I would say, is finished with the case study. Very simple case study, because such projects are really many. And the main idea in this project, which was the container school for preliminary students or preliminary school students in Germany and close to Raunheim, was clearly defined for the 3 years time frame. So our job was a little bit complicated because of the grant properties, grant conditions, which wasn't very favorable actually in this area. It was a silt from sandy to strongly sandy and silty sands. We installed in this location over 150 screws with 52 beam connections. The whole investment was around 100,000 of euro. And what is also important from our point of view, we managed really to prepare or to complete the foundation system within 6 days with a team of 4 people. And as you see, just to have understanding how it works, first of all, the locations for screwing the piles into the ground are marked. They are the places where you marked it with Hilti equipment or something like this, something similar. Then really screw piles are screwed into the ground using such excavators with drilling masts or self-propelled drills. Usually this is a team of 2 people which really work with such device. And it's really very, very quick technology. But the most important and most, I would say, interesting thing is that after the planned usage period, in that case, they've been 3 years, the investor can decide, okay, I want to remove the construction. And we've been asked really to unscrew also our foundations after this time. So we have inspected the 100% of the elements which we have installed. We really, every component was carefully inspected, and to guarantee particularly the quality of the product and the reliability and the possibility to use them again. Okay, so that after unscrewing process, we have inspected 100% of the elements, and the majority of parts, they've been used once again in internal other projects, again ensuring really, I would say, good quality, sustainability, and also efficiency. You can imagine that the economical calculation in such process is very positive for such investments. For us as a producer, it is also a very good opportunity if we can really make inspection because of continuous improvement process and our, for example, production processes. We can really focus on improving our technology to provide even better corrosion protection. And this is, in my opinion, a really valuable system for the investors and for, I would say, the building industry at the moment. So in conclusion, actually, I would emphasize once again that the system of WFS, it means screw foundation piles, in our opinion, they represent really new thinking about the foundations. The system is durable, sustainable, and flexible. And I hope that I picked your interest. And if you have really more questions, if you would like to know more details about the system, about the applications, then of course after webinar you can contact us directly. Marta, Kacper, myself, we will answer your questions. So thank you very much really for the attention, and me and my colleague Kacper, yeah, we are at your disposal, you know, during the Q&A session. Thank you very much.
Thanks very much for that, Peter. That was really interesting. I think one thing that I've definitely noted down and I'll take away from it is just one of the things you said in the last couple of slides, because often manufacturers, when you talk to them about circular economy, struggle to get their head around it, because they're basically saying, what you're asking us to produce less or cannibalize our own market by trying to facilitate it.
Yep.
But I think that was a really interesting point where you said, when you do have the opportunity to get involved at the end of the first life of the product, it's a continuous improvement, beneficial from a continuous improvement aspect. You can see, you know, where your product could be improved, different protective coatings, and having that conversation with the client. I'm just wondering, does your business model at the moment, or would you look at your business model including taking back any of the product, or do you just facilitate your client to use it again with another of the same client's projects?
Well, at the moment, we are focused really on the development of our business. We are a relatively young company on the market. We are the youngest child of Winkelmann Group. So, you know, the company has been launched in 2023. So that the first full business year was 2024. And therefore, you know, first idea is really to develop the markets. But of course, the main idea of the product is to reuse again the products so much as possible. Therefore, the business model at the moment includes planning, includes installation, includes delivery, and also reusing of the delivered products.
Great, thank you. So we're going to open up to Q&A now, but just quickly, I should have mentioned it at the beginning, that coincidentally, we've actually, 3 of our 4 presenters are actually patron members of our of the Alliance for Sustainable Building Products. And we do charge a little for non-members to attend these webinars, because our organisation is a not-for-profit, and one of the benefits that we I guess pitch to people when they look at becoming a member of the ASBP is that our webinars generally are very low cost for members or free for members. There's lots of other different member benefits around research projects and case studies and networking. So again, I'd encourage you to have a look at becoming a member of the ASBP if you're not already. And again, over and above, Cleveland Steel and Tubes support as a campaign sponsor. As I say, Roy is also a patron member, as is Iain and Andy at Heyne Tillett Steel. So just to have a quick look at some of these questions, I think to your delight, there's a warranty question, particularly for Iain and Roy. I think that would be quite interesting, and also maybe Andy's take on that, where you know, the reuse sector does have difficulty with different materials about re-warrantying, but I think we've kind of nailed that with steel. I don't know if Roy or Iain want to go first on that, please.
Do you want to take that one, Roy, or do you want me to go with it?
I can go. The great thing about steel is we can retest it.
Yep.
So providing you've got the traceability, you can provide all of the same data that you get from a mill when you buy new. So as long as it's dimensionally correct, we can then provide all of the mechanical properties, the chemical properties of the steel. In essence, that allows us as a business, when we sell it, to warrant it according to that information. Touch wood, in 50 years of trading, this isn't a problem that we've had, i.e. we've not had to stand by a warranty because of failure of performance of material. Workmanship, especially downstream from us, can be potentially a problem, but not the steel itself.
Yeah. I'd second that. The steel is the steel, and there is ways to send it away to get recertified, to know the properties of the steel, you know, the thickness of the steel, everything like that. So yeah, only thing that I'd maybe say is that I've seen more and more some things in rail. I was doing a project, I was quoting, it was just 4 piles getting quoted, but they wanted the design life of 125 years or something, you know. And I think, I can't remember, I ended up, the piles ended up being galvanized and then painted over the top of the galvanized and everything. And it was just, I don't know, I could have offered thicker material as well for a cheaper rate. I could have went up a size in pile, but the design was the design for the size, and I couldn't change it. It was so things like that is the only thing I would say is, you know, the lifespan that some designs go to. But yeah, the actual steel grades and everything can all be tested.
Thank you. Andy, a couple for you, I think. The first couple of questions there, I don't know if you can see on the
I've
Q&A.
had a quick look. Yeah. Typically speaking, factors of safety were a lot higher historically, so serviceability wasn't really what was governing the design. So I would say, yeah, probably design serviceability, but design to a factor of safety. But I would want to say one thing about the strength is obviously the quality of the concrete mixes, and the control of concrete mixes historically is probably a bit sketchy. So that's one of the reasons why we take so many samples of the piles and just check the grades when we're doing these works, just to, you know, check that there's no discrepancies and where, you know, the mixes aren't too tricky. Record availability. So yeah, some sites, when we're looking at existing foundations, reuse jobs, archive information could be, you know, very comprehensive. We could have piling records, or we could have nothing. So, you know, it really is horses for courses, site specific. The BRE urban sort of reuse handbook, or PAR reuse handbook, makes recommendations for testing sort of 10% when you're looking at a fairly, you know, comprehensive level of investigative works, and 3% is a sort of poor level of works when we're looking at reuse jobs. But, you know, you've got 100 piles on site that's looking at 10 piles, so often this can be led by insurers and how many piles they think are satisfactory for sort of the project. Is there anything else on that? Oh, justification. Yeah, simply can be a sort of a back calculation exercise, a comparison between existing and proposed load takedown, and comparing the former design code with more current design standards. So a fairly simple exercise, or it could be a more complicated 3D finite element analysis, which involves a lot more work. And that's mainly to look at sort of interactions between existing foundations or changes in load, or maybe you're looking to put some supplementary strengthening works in. It might require a slightly more comprehensive analysis, but again, it'll be dictated by the sort of the level of complexity of the development.
Thank you. Next question about materials passports. Have Well, I guess Iain, Roy, or Peter, is that something that you've looked at?
For me, I've struggled with the material passports from steel, because when you've got the test certificate with the size and the grade on it, I genuinely think in most cases you've got all the information that's required carrying forward. Not least of which because steel's an adaptable product. So the fact it might be a 26-meter long, I don't know, fender pile for a marine application, that tube is still the original tube and can carry on to be that pretty much indefinitely. So I think, I mean, we have the traceability, we've got the record keeping, but versus other products, I think most of the basic data is available for steel. It's actually only a question of keeping it. And those certificates should be kept with the design package and with the completion packages of jobs.
And I guess when you've got the EPDs available as well, to marry it with that, you've got the environmental information there as well. Anything to add, anybody else on that? Okay. Typical utilization ratio that existing pile foundation has. Again,
this is variable. Obviously, designs differ, source strengths differ. It's not a sort of an answer, a cover-all answer, unfortunately. So you might take into consideration historic loading on site, and you might take a view that you can reduce the partial factors or lump factors based on that existing loading condition. But unfortunately, it's sort of, again, a sort of case-by-case basis, I'm afraid. I mean, if maybe reference to LDSA guidance gives you a bit of a steer on how you can look at reducing partial factors and lump factors based on load testing. And you could maybe argue that the existing building is demonstrating load testing to a degree. But yeah, as I say, it does require a bit more thought, and it does vary case by case.
Thank you. Then a couple of questions for Peter around cost savings, if components are returned, what the maximum loading per pile, and what ground conditions that would not be suitable for screw piles. You happy to answer that, Peter, or does Casper want to answer that?
Yeah, the cost savings is always the question of the benchmark. Yeah, so that depends on with which kind of foundations do you make the comparison. But generally, what we do, we try really always be focused on not only the costs, but also on the time. And if you really include in the calculation time, as I said in my presentation by screw piles, we had three main, I would say, targets and objectives. And one of that, it was elimination of this wet process and plus reduction of the time, which you really need to make foundation. So if you include the time, of course, this calculation looks completely different as you just take in consideration pure costs on the building side. But taking really all the values which you can, which you should really calculate, in our opinion, our product is really very competitive to traditional ways of foundations.
The maximum loading per pile?
Well, we calculate for this modular system 140 millimeters, around 125 kilonewton for vertical forces. And if you need more, of course, is that what I said, we collect them into the groups and we really connect them with traverses with this connection beams.
Thank you. And then are there any ground conditions that would not be suitable for screw piles? I'm imagining that there are, but is that?
Yes, you know, in this short history, because really this not full 2 years we are on the market, we usually work with the grant conditions which are not standard, I would say. So we are always in the beginning, we've been called for the special grant conditions and difficult grant conditions. And these machines which I presented, they can work really in quite all normal grant conditions. But if you have a typical, I would say, rock soils, yeah, then we use something what we call impact hammer, and we can then really make pre-drilling up to 3 meters. This is a diameter of 90 millimeters, so that until now we don't have really a case where we could say no, we are not able to make this foundation in that particular case on the building site.
Thank you. I think that's all of our questions. Oh, another one's popped up from Mark. When assessing the existing piles, were pile caps or pile rafts or ground floor slabs taking into consideration to resist load?
I think as a first pass, we'd look at piles to start with. If we can get that system to work without taking any contribution from the underlying sort of the interface with the bottom of the slab and the raft, then yeah, that, you know, we'd have to take a view on that. I think for pile caps, no, it would just be straight into the piles. We wouldn't look at any contribution from the underside of the cap.
Thank you. I think this is quite a good one to finish on from an anonymous attendee. Awareness raising and education are significant challenges for promoting the uptake of available and viable circular solutions. What do you think is needed to normalise these solutions, and do you see your clients promoting the approaches taken? Who's going to go first?
I will, I'm never shy. I would say basically it's just to keep thinking about it. The example I give where we see diagrams of buildings where people are thinking about the circular economy solution for the building, but the foundation is just a grey sketch underneath it. And it's the same thing with what rail. We've dealt with rail. Network Rail are still using drawings from 1968. If it just is a question of all the time pushing the agenda, because the solutions work. So in actual fact, the more times we get things adopted, the more comfortable everybody gets with it. The piling industry are comfortable with these solutions, absolutely 100%. So it's more a question of ensuring that up the chain, people are listening and adopting and challenging the normal solutions, if you like.
Thank you.
Mm-hmm.
Iain?
Yeah. Just similar. For me, it is all about being able to get involved, or I would like to get involved with maybe some of our projects maybe earlier on, where if they're going down the repurposed steel, what material is out there to start with? You know, it can't get so far down the chain that by the time it comes to the stockholders, they can't use repurposed material because the size that it's all been designed on isn't actually available. And you know, I've certainly come across that in projects. So that's one thing, but it is challenging to get in front of those people, get in front of that right the right engineers, you know, the right people right at the start of the project, you know. So it's changing that mentality, I think, you know, from them being at university even, you know, and the idea of repurposed material. So when they're coming straight out, you know, it's a question that's asked, and that's, you know, my responsibility, but it's also the responsibility of everybody to ask these questions, you know.
Yeah, and, absolutely. And I know that's something that we're quite conscious of within the ASBP, that we've got, as I said at the beginning, we've got an awful lot of really useful practical material that maybe we need to start engaging a little bit more with, perhaps even colleges and schools as well as universities, and trying to kind of repackage our information to help support the industry, feed that back down as part of the education process, because that is really, really important. Peter, I don't know if you've got any comments on normalizing solutions and seeing your clients promote the approaches.
Yeah. I think, particularly that we are so young company with really ambitious targets. Our job is really to make the system very popular. And really, for example, such opportunity like you have offered, yeah, so that we can really speak about a completely new approach to the foundation system, reuse fully the system after the certain period of time. It means the target groups which we have in focus, as the colleagues said, that the students that also, the structural engineers to make it sure that really the professionals can and are aware about the advantages of the system. So from my point of view, this is really a big opportunity, but also a responsibility to make the system well recognized on the market.
Thank you. Andy, if you want to give your kind of comments and anything as well.
Yeah.
Just a last question that's popped in about building insurance as well, regarding reuse and screw piling.
I'm not entirely sure about screw piling. I might have to refer that to somebody else, I'm afraid.
Peter, maybe.
I will quickly chip in about the question we were just talking about. Just to Ian's point, is that the sort of the people coming out of university, they're more aspirational for sustainable practices, and we notice that when the graduates are coming through, that they're really pushing that agenda, and that they're asking those questions, which is the right thing to do, and they've just got a different mindset as maybe we've had more traditionally about sticking more concrete in the ground because that's how we're going to get the building to work. I think from our perspective is that as a company, our initial approach is looking at reuse, and then if we can't get the reuse to work, then we're infilling those gaps. But I think that it's going to be helped by the sort of next generation actually actively wanting to do it, but we need to nurture that, and we need to engage, and we need to make sure that we're allowing them and allowing everybody to get on board and sort of drive that agenda, or not agenda, but drive that process.
Okay. So just to the last question, and whilst this is being answered, I think Larry's just popped the feedback form link again into the chat. If you could just quickly fill that out, that'd be much appreciated. So last question to Peter, just on the building insurance. I don't know if you've got any comment on that, how the insurance industry generally regards reuse and screw piling.
Could you please repeat the question?
From a building insurance perspective, do
Yes.
you find that screw piling has positive or negative connotations for the building insurance?
Well, this is the screw piling system is developed or is planned as each foundation. So really, we guarantee that the structural calculations are correct. And from the durability and from the sustainability of the system, it's the same system. The rules are the same as for other foundations. So we plan the foundations for minimum 50 years. And we have to fulfill all requirements and Eurocodes norms like in other case of foundation. So that, in my opinion, this will be a very positive reaction on that, because the all requirements are fulfilled, including, of course, anti-corrosion protection.
Thank you. So thank you ever so much to all of our panelists. Oh,
sorry, just very quickly, it just occurred to me I've missed out a very important point on all of this. Eurocode 3, which is for piling, actually specifically allows for reuse and always has done. So in the 10 or 15 years I've been campaigning on repurposing and reusing material, Eurocode 3, which covers piling, actually did already have reuse within it. So the insurers are comfortable with it because it's a fitness of purpose question, as per what Peter's just said. It's all laid out. Sorry.
No, that's great. I don't know if you could pop a link in the chat, Roy, possibly, if you.
Link might be a bit strong. I'll find it.
We can include it somewhere within the presentations when we get them up onto the website in the next month or so. So I think Simon's just appeared, so I think you perhaps might want to say a quick word. But just thank you very much from me to all the panelists for your effort and time this afternoon. I think that's been a really interesting session. So over to Simon.
Yeah, thanks, Debbie. Yeah, good afternoon, everybody. So I'm Simon Corby. I'm CEO at the Alliance for Sustainable Building Products. I just wanted to reach out and say a huge thank you to you all for a really interesting webinar. Yeah, we look forward to working with you as we try and upskill the industry and we try and reduce the amount of carbon emissions linked to the built environment. And we follow up with our mission, which is to turn the built environment into a low carbon and healthy endeavour. So yeah, without further ado, I'll hand you back to Debbie. And thanks, speakers. It's been a really interesting webinar. I've learnt loads, and I'm sure our delegates have too. We are recording this. We will be sending it out. We then host it on our website, and in a couple of weeks, it'll be free to everyone. And I have just written to the IStructE, so the Institute of Structural Engineers, so Will Arnold, and I will send them a recording of this as well, because actually it's structural engineers that this really is looking at, and so I'll send it to them and they can circulate it as a free resource. Over to you, Debbie. Thank you.
Thanks, Simon.
Thank you very much.
Thank you very much, everybody. Timely finish, 2 o'clock. Have a good afternoon. Thank you.
Thank
Thank you
you.
very much. Bye-bye.
Thanks.